Hey everyone, welcome to Tutorial Upgrade. In this tutorial, I will show you 4 different ways to create an in-game button for Unity. Each one will grow on the previous features. At the end, we should have something that looks like this. Let's begin by making our first button. To make this button work, we'll use the onMouseOver and onMouseDown functions. First, I'll create a simple button script, and we will create a public animation that we can play when we click our button. The next thing we want to do is create a start function that sets up our code for execution. We just want to make sure that everything is plugged in before we start running, as it is one of the most common errors people encounter. I'll simply check and see if our animation variable is not null. If it is, I'll log an error to the console. This is a quick and easy way to let yourself or your team know that something is wrong. Next, we have the onMouseDown and onMouseOver functions. These functions are ones that you get when you inherit from mono behavior. They must be spelled exactly as I'm showing you for these to work. Now, the onMouseDown function is called only once when the player clicks on an object that has this class attached. And the onMouseOver function is similar to this, except in 2 ways. First is that the function is called when the user keeps the mouse over an object, and the second is that onMouseOver keeps getting called over and over as long as the player has their mouse over the object. Now we just need to hook everything up. We'll start by putting an animation component onto our object that we want to animate. Then we will put our button script onto our button and drag our object that we want to animate onto our button. We should now be able to walk up to our button, click it, and see our animation play. Now this works as a baby's first button, but there is a bug in our setup that I'll talk about in the 4th part. This does remind me of what my university professor once told me. Your code only has a bug if you intend to fix it, otherwise it's just a feature. Though he did always say that about his code we had to use, and we had to fix everything in our assignments. Huh. Anyway, back to our button. What can we do to make it better? What can we do if we want our button to work with just more than one animation? Or we want to work with different types of objects or scripts? That's where Unity events come in, and where we'll begin working on our second button. Events are a special way for a class or object to notify other objects that something has happened. The Microsoft C# documentation calls objects that send information publishers. On the other hand, objects that receive information are called subscribers. For this tutorial, our button will be a publisher, and our animation, or anything that we want to play or change, will be a subscriber. In our code, we will replace the animation with a Unity event. Note, to use Unity events, you will need to include the using statement using Unity engine.events. This event is how we will send information to any object that subscribes to our event. There are 2 ways to subscribe to an event. The first is in code, and the second is through setting up our objects in Unity itself. For this video, I'll be using the second method. For more information on events and how to set them up in code, there will be a link in the description to the Unity documentation. Since we are now using an event and no longer an animation, we can't just call play anymore. What we have to do is call invoke. The Unity documentation for UnityEvent.invoke says that it will invoke all register callbacks. Now I generally prefer a definition not to contain the word itself it is trying to explain. Simply put, invoke can be thought of as a for loop calling all functions or objects that are subscribed to the event. And since we will want to play an animation with our new button, we will also create a simple animation script that will sit on the object we want to animate. We will only need one function called play. It will take an animation as its parameter. Now, let's take a look at our updated button in action. We'll hook up the components, add the animation, and hit play. Now that we have a more advanced button that uses Unity events, we have a problem. Well, we have 2 of them. First, what happens when the button is clicked multiple times in succession? I don't think that's how a gate's supposed to open. To fix this, we need to limit how often the user can push the button. And the second problem we have is that we're not giving any player feedback. We don't have a way of showing when a button is pressed, active, or busy. To fix this, we're going to add 3 states to our button. a ready state, showing the player that the button is ready to be pushed, a hover state to let the user know that they are pointing at the button that can be clicked, and lastly a busy state, showing that the button is waiting for whatever action to be completed before it can be pushed again. To show these states, we'll just change the material on our button, but with some trial and error you could do other things like play an animation or swap out the model. I won't go into too much detail here, but what we're trying to do is called game feel. Basically the act of giving the player good, clear, and or awesome feedback on what is happening. At the very least, we want the option of doing it later on down the line. If you're interested in making your game feel better, which you should, there will be 3 links in the description that will go into more detail about game feel and game feedback. Before we go on to make a new fancy button, I'm going to update the animation player to take in an animator and a string. This is just to make it easier for me to handle multiple animations. Okay, now back to our new fancy button. We will want to add a new type of function that I'll call use and a new function called onMouseExit. We will also need to add some more functionality to our old functions. To begin, we need to create a few variables. Since I want to change the material on our button, we need a reference to the mesh renderer. The mesh renderer does what its name says. It applies the material to our button and it renders our object into the scene at the position defined by our button's transform component. And again, there will be a link in the description to the Unity documentation on mesh renderers. Next, we will want 3 material variables, 1 private variable for our default material, and 2 public variables for our highlight material and our used material. And lastly, we will want 2 floats, the first of which we want as a public variable for how long of a cooldown our button should have. And second, we will want to store the last time we activated our button. Now we can begin changing our existing functions. In Start, we just need to add a get component to the current mesh renderer that is attached to our button and save the current material. Next, we will change our onMouseDown function. We have a button cooldown we have to factor in before we can invoke our event. The first thing we'll do is capture the current time. Then we will want to see if the current time is greater than the last time the button was activated plus our cooldown time. If that's true, we will set the last activated time to current time, then call a vote on our event, and then we'll call use, but in a new way you may not be familiar with. I'll talk about it in a few paragraphs. Okay, now back to the code. OnMouseOver will be nearly the same as OnMouseDown, except we are replacing a material inside the if statement. Don't tell my professors, but we'll just use copy and paste here. And then, inside the if statement, we'll grab our stored mesh renderer and replace its material with our highlight material. For the first of our 2 new functions, we're going to create the onMouseExit function. Just like the onMouseOver and onMouseDown functions, you get onMouseExit when you inherit from monoBehavior. The onMouseExit function is called whenever the player's cursor is no longer on the object that has this class attached. Inside of onMouseExit will be nearly identical to the onMouseOver function. We just need to change the highlight material to our old stored material. So, we'll close our eyes and hope the copy and paste keys still work, and then replace the highlight material, and we're good to go. The last thing we have to do is create that new type of function I was talking about. Except it's not really a function, it's a coroutine. Coroutines are kind of hard to explain. Coroutines, defined by Unity, are functions that can suspend their execution until the given yield instruction finishes, meaning that the execution of a coroutine can be paused at any point until the yield statement. Coroutines are excellent when modeling behavior over several frames. Now I don't expect all of that to make sense, but this video is already getting long, so I won't be fully explaining how coroutines work in this video. But, say it with me, there will be some more links in the description to help you learn, as well as some tutorials that use coroutines. For now, and as long as you don't tell anybody, we can just copy and paste my code and I'll go over it at a high level. We'll call our coroutine use. Unlike the other functions, you can name this whatever you want. A coroutine must also have a return type of IEnumerator. Trusty Microsoft says an IEnumerator supports a simple iteration over a non-generic collection. It's not really that important what it is, we just need to return it. And no, I'm not skipping a better explanation because I don't know what Microsoft is talking about. We're just short on time. Anyway, as you saw before, a coroutine can't be called like a regular function. You must first pass it to the start coroutine function, which, well, starts the coroutine. Inside the coroutine, when it first starts, we'll set our MeshRenders material to our used material, and then we'll call yield return new, wait for seconds, and pass in our cooldown time. What this does is say to our program, I'm done for now. Call me again right where I left off after X number of seconds. And lastly, we'll set our material back to our default material. Now, once again, all we have to do is plug everything in and we should be ready to go. Let's test and make sure everything works. It should, probably. And now for our fourth and final iteration of our button. Ta-da! Our advanced button. Okay. I know it looks identical, but I did change the name of the functions. I know. Thank you. Now I know what I said, that the functions must be named exactly as they come from MonoBehavior, but that's only if you want MonoBehavior handling those functions for you. If you remember back in part 1, I said that our new button had a bug. You see, the mouse functions from MonoBehavior don't care how far away you are from the object. So unless my game character has Go-Go Gadget extendo arms, I want to set how close my player needs to be to use the button. Now that could be difficult to do inside of our button script, so I'm going to create a player interaction script that goes on our player's camera. I won't be going into too much detail because, well, again, this video is getting kind of long, and I also want to make a full separate video on just implementing a fleshed out player interaction system later down the line. The quick of it is, we first grab the camera in the start function. Then, in the update loop, I will fire a raycast from the camera's position and rotation and see if that raycast hits an object that is in range. Then, checking if the layer of the hit object is equal to my button layer. If it does, I grab the button component and call its onHover method. Next, I check if the user has left clicked. Then, we call the button's activation function. It should just work exactly like our old button. Keyword should, as in it might work, but it's not my fault if it doesn't. All we need to do is replace our script on the button with our new script. All the variables will be the same. Our object that we want to animate is also the same. All we have to do is go onto the camera, add our player interaction script, and fill in the camera variable. And then we should hit play, and everything should work. You now have 4 different iterations of buttons and hopefully a good understanding of how we got from the beginning to the end. If you have any questions or suggestions for future topics or things that you'd like me to cover, please leave a comment. Also, for anyone that's still here, congrats! We just got through my first tutorial together. If you have any suggestions or constructive criticism, I'd be happy to hear it down in the comment section. See you next time.